You've covered all the basics now, so we're ready to watch the techniques themselves. A good all-around iron to have is a 30-watt pencil type with changeable tips. The larger size tip will be used first. It's fully inserted and tightened into place. While the tip is heating up, cord solder is held against it until the tip is tinned. Between uses, the iron is kept in its cubby. First, we'll show you how to solder leads to turret terminals. And since the wires are insulated ones, they will first have to be stripped and tinned. Stripping can be done in several ways. One way is with a mechanical stripper. This kind, if it's been properly calibrated to control the depth of the cut, can provide a clean strip and do it without nicking the wire. This type of stripper should not be used. The V-shaped notches in the blades do not conform to a round wire, and nicking the wire is the usual result. Using a knife blade to cut the insulation is another unacceptable method. It's almost certain to damage the wire. A safer and more versatile tool is the thermal stripper, which has a pair of heated tips for melting or softening the insulation rather than cutting it. Teflon insulation is as easy to strip as PVC with a thermal stripper. In use, the stop block assembly is first adjusted to give the proper stripped length. Then the thermal stripper is plugged into a power source, and the tip temperature is set, depending upon the type of insulation on the wire. High for Teflon, lower for PVC. The heating of the tips is controlled by a foot switch. When the switch is depressed, power goes to the tips, heating them instantly. When the switch is released, they rapidly cool. This gives the operator precise control over when the heat starts and how long it stays on. The wire is inserted and held lightly, and the foot switch depressed to melt the insulation. The tool or wire is rotated as penetration occurs. The advantage of a thermal stripper is that it reduces the chances of nicking the wire and safely removes all common types of insulation. It can be used on various types of plastic and on wires of varying thickness, including shielded cable. Before using the iron each time, it is cleaned by first wiping it on a non-contaminating wire brush made of stainless steel. Then it's touched lightly and quickly on a wet sponge. The brush removes any scale or solder residue that may be on the tip. Still there, however, is a thin film of oxide, and the wet sponge is used to shock them off, leaving the surface bright and clean. Tinning the wires is the next step, and there's a simple technique for doing that. Notice how the wire is moved across the iron tip, first toward the insulation, and then away from it and off the end. When done this way, no solder will be pushed up under the insulation. Remember, there should always be a gap left between the end of the insulation and the beginning of the tinning. Using a pair of chain-nosed or round-nosed pliers, the tinned end is now formed, the loop is cut, the wire placed in position for soldering. The actual size of the loop will vary, depending on the specifications for the particular job. The loop may be a 180-degree one, which makes removal easy, or it may be as much as 360 degrees. We recommend a 270-degree wrap to ensure a tight mechanical connection before soldering. When only one wire is placed on a terminal, it is placed in the lower section, flat down against the base. In this way, any mechanical stresses will be transmitted to the board, not the terminal. If two wires are connected, they are brought in from the same side and positioned so that insulated portions of the wires are in contact, one on top of the other. Note the insulation gap that's been left in the wire. This is done so that during soldering, the insulation won't melt into the wire. Now let's watch the soldering, first in real time, and you'll see there are 4 basic steps involved. This time we're going to stop the action at each step. This is the first one, putting the iron at the point of maximum thermal mass. Here is step number 2. A solder bridge is made to increase the thermal linkage between tip and work. Step number 3. Solder is applied on the opposite side from the iron. it's painted on and then removed while the iron's still there. Step 4. Now the iron is withdrawn with a wiping motion. Now we see it in real time again, and with just the right amount of solder going on. How do we know this is the right amount? What do we look for when judging a solder joint? First, we remove all the flux so that we can examine the joint. This is the way a good solder joint looks. It's bright and shiny, and the solder has feathered out smoothly, showing good wetting action along all the elements of the joint. The area on the side is known as a fillet, and on a good solder joint, the fillet is always slightly concave. This joint is unacceptable because there's too little solder. The joint may otherwise look good, but there's too little solder on it for acceptable mechanical strength. Also unacceptable is the joint with excess solder. The fillets here are convex, not concave, and the outline of the wire has been hidden in a mound of solder. Soldering for inspectability is a basic rule to follow. It means soldering so that when you're finished, you're still able to see the outline of the individual strands of wire in the joint. This joint has been soldered for inspectability. In this case, there's too much solder on the joint. The outline is gone, and the true condition of the joint cannot be determined.